Hello students, in this video I am going to discuss about the Wurtz reaction. I know you all understand the Wurtz reaction, but here I am going to tell you why this reaction is so much fascinating. When we understand the concept behind any organic reactions and the importance of that reaction, we'll get interest to learn organic chemistry. And always remember, organic chemistry is the match winner for all the students. So now let's understand the Wurtz reaction. Why this reaction is so much fascinating in organic chemistry? Because in this reaction here we can see we are using metal as a reagent. If you remember previously whatever the reactions we have learned where the reactant is organic compounds, reagents are also organic compounds. Sometimes we use metal as a catalyst. Like for the reduction of alkene or alkyne, we are using palladium as a catalyst. Ranitidine is a catalyst. This is the one of the most old and traditional reaction where we are using metal as a reactant. It's like we are slowly moving towards the organometallic reactions. Now here we can see we have used alkyl halide and sodium as a reagent, dry ether as a solvent. Understand that here dry ether used as a solvent, not as a reactant or reagent. Why we use dry ether as a solvent whenever we use metal like sodium or Grignard reagent or lithium? Because these sodium, lithium, Grignard reagent, they are highly reactive in nature. That means they can react with water or oxygen present in the solvent. Then what will happen? The desired reaction will not take place. To avoid this problem, here we use dry ether as a solvent. And this particular reaction is also known as a coupling reaction. Due to this coupling reaction, there is a carbon-carbon bond formation is happening. Here you can see, here we have used bromomethane. So, due to Wurtz reaction, there is a carbon-carbon bond formation. Though we write like a CH3 like ethane, but ethane we know that this is a carbon-carbon bond formation. That's why this reaction is so much important in organic chemistry. Now, one of the disadvantage of Wurtz reaction is that when you use different kind of alkyl halide, like here you can see we have used iodoethane, means where the number of carbon atoms are 2, and here we have used iodopropane, here number of carbon atoms are 3. So, what we have discussed previously that here this ethyl group CH3CH2 and this propyl group, the carbon-carbon bond formation will happen. So that means ethyl and propyl we should get pentane. You can see here I have drawn the structure pentane. And you can see here all this carbon-carbon bond formation is happening. Like this is CH3CH2CH3. Now this is CH2CH3. So this is the new bond is forming. But at the same time we will be getting mixture of product. These two ethyl group combined will be getting butane. When all these propyl group combined will be getting hexane. So to avoid this problem or to overcome this problem, a new reaction was proposed that is called the Corey-House reaction. That I'll be explaining in my next video.